Hello again, everyone. All right, we are ready for our very last video on rational functions. And so this will wrap up our conversation for rationals, which means we're halfway through the unit, which is pretty cool. Okay, so there is a new document that goes with this activity. Let me pull mine up and share it with you so that we are looking at it together. Okay, so this is the final document and it just kind of wraps everything up that we've been talking about, and there is also a context problem at the bottom for us to discuss because there will be a contextual problem on your exam. So first of all, there's two problems in this activity. We're going to do one of them together right now on the video, and then you will be in charge of doing number two on your own as homework and submitting proof, of course, that you followed along with this activity and completed it. So what we're going to do is we're going to fill in all of these key criteria, all these key components. We've got the vertical asymptote, the domain, the vertical intercept, horizontal asymptote, HA is asymptote, R for range, and then HI for horizontal intercept. Now, some of these we've talked about already on previous videos, others it will be new. So first and foremost, the vertical asymptote, if you recall, is when the denominator is equal to 0. So for this particular example, x minus 5 equals 0. If you simply add 5 to both sides, then you will get that the vertical asymptote is at x equals 5. So the vertical asymptote is at x equals 5. Now, since the vertical asymptote is at x equals 5, that means that our domain is simply everything except for that. So if you recall from a previous discussion, it's just all real numbers, but we do need to exclude. So you can say x and then the not equal to bar. I don't have a not equal to bar right now. If you were just using your pencil, you can say not equal to, but I'm just going to say the English word except x equals 5. So you can say it with English words, or you can use a not equal to bar right there. Okay, so for the vertical intercept, I mean, here's where obviously we can use Desmos for this, but I also thought it would be nice to just talk about the algebra because it doesn't take long at all to do the intercepts with a pencil. So 2x minus 3, okay, so y equals 2x minus 3, and then divided by x minus 5. Okay, so once you have the graph produced, and again, you guys are allowed to use Desmos, so you know, this is not that hard, hopefully, to type into Desmos. The vertical intercept, you know, it's just right there. You just touch it. It's at 0, 0.6. But I did want to talk about today, just because it's something I said a lot during class, and it is definitely still true, negative 0.6. If you're wanting to find the vertical intercept, ladies and gents, with a pencil, I don't care what chapter you're in. You just plug in x for 0. So if you just grab your pencil and put a 0 everywhere that you once saw an x, 2 times 0 minus 3, and then divide that by 0 minus 5, oh, positive 0.6. If you just plug a 0 in, you're going to get 0.6. So it's, you know, with a pencil, you can plug in 0. With Desmos, you can just touch it. But either way, it is at 0, positive 0.6. Okay, horizontal asymptote. All right, asymptote. So horizontal asymptote comes from the coefficients of the variable. So where's my variable? Right here. So what are the coefficients of the variable? Well, there's a 2 on top and a 1 on the bottom. So 2 over 1, which means, of course, as far as your writing it goes, your horizontal asymptote, just like your vertical asymptote, has to be identified by its letter. So y equals, remember it's a horizontal line, so it cuts through the vertical axis at a y value of 2 over 1, but 2 over 1 is really just 2. So y equals 2 is the horizontal asymptote. Okay, range is something we haven't talked about yet, but I'm hoping that you can take this leap of faith with me. All right, here we go. Let me clear out all my drawings. There we go, clear. If we know that the horizontal asymptote is at y equals 2, so here's my 2 asymptotes. Come on, there we go. So vertical asymptote is at 5, horizontal asymptote is at 2. So if the horizontal asymptote is at 2, well then the range is everywhere except 2. Think about it. This curve up here lives above that horizontal barrier at 2. This curve down here lives below the horizontal barrier at 2. So where is the range? It is everywhere except 2. So we're going to say that the same way we did in our domain, and that is that it's all real numbers. Now you could say y not equal to. I don't have the not equal to key right now in this program, but you just with your pencil, you can do an equals with a slash through it. Or you can just say except a y value of 2. So again, the English word except, or you can just use the not equal to button. Okay, so all that is mostly review. I hope. Horizontal intercept. Okay, check this out. Horizontal intercept on Desmos. Not too bad. Touch. It's right there. So just like you can touch the vertical intercept, you can certainly touch the horizontal intercept. It is at 1.5, 0. Done. But I do want you to see the algebra behind this. So even though I technically know that my answer is 1.5, 0, I am going to talk you through the algebra for this because it's really not that bad at all. And once again, this is an algebra class, and I want you to see how some of that works. So I need to plug in my little tablet thingy, and then we can write with more ease. Okay, so your function for this one was, let me remind myself, 2x minus 3 over x minus 5. Okay, so it was 2x minus 3 over x minus 5. Okay, and now we're talking horizontal intercept. So just like with the vertical intercept, you can find the vertical intercept by just plugging 0 in for x. For the vertical intercept, plug a 0 in for x. Well, for the horizontal intercept, you plug a 0 in for y. The output is now 0. So it's going to say 0 equals 2x minus 3 over x minus 5. And when you first look at that, you might say to yourself, well, gosh, how the heck do you solve that? That's kind of a weird looking equation. And on first glance, yeah, I hear you. It's a little bit weird looking, but do you want to know why it's weird looking? Because there's a fraction in it. If that fraction weren't there, you wouldn't be so intimidated. And that is why the very first thing you do is you get rid of the denominator. And how do you get rid of the denominator? Well, fraction bars mean divide, yes? Division means divide. Fractions mean divide. So what's the opposite of division? Multiplication. You're going to multiply by the denominator. Now the whole point of that is because this multiplication is the inverse of that division. So those just undo each other. But now check this out. Guys, what's x minus 5 times 0? What's anything times 0? Yeah, 0. So you end up just having to solve that numerator equation because the denominator, when you multiply it over, it just gets zeroed out. So all you have to do is solve for when 2x minus 3 equals 0. And that, my friends, is just a couple of quick algebraic steps. And notice 3 divided by 2 is 1.5. Just like we saw in Desmos, the x value is 1.5 when the y value is 0. Ta-da! Okay, so we have Desmos, of course we do, but we also have algebra, all right? So you've got your horizontal intercept at 1.5 comma 0, you've got your vertical intercept at 0 comma 6. When you actually go to graph this, you can certainly do everything that I've done on Desmos and just put a picture or a screenshot of this graph into your document. That totally works for me. If you are going to do it by hand, make sure that when you draw it with a pencil, that you draw in all of the barriers. So like what I mean is this is going to be a ridiculously rough sketch, so bear with me here, people. But if you were drawing it by hand, I should still be able to see that the vertical intercept, I'm sorry, the vertical asymptote was at 5, right? Yeah, it was at 5. So you should have like 1, 2, 3, 4, 5, like label, scale, all that good stuff. Tell me that it's at 5. And then I should also be able to see that the vertical, horizontal asymptote is at, how do I get this out of the way? You, go away. Up here. Up here. Oh, I don't know. This is confusing. This is why I don't like using the mouse thingy. Okay, anyways, the horizontal asymptote we said was at 2. So you should very clearly identify 1, 2, and then your asymptote gets drawn in at a y value of 2, okay? And then, and only then, will you identify that the vertical intercept we said was at 0.6, the horizontal intercept was at 1.5, and now that you have that all drawn, you can do your best to sketch with your pencil what the graph would look like. So main takeaway message here, kids, for drawing your graphs is that I expect them to be neat, and even neater than mine, please, because I'm using a mouse and a trackpad and who knows what all. But label your axes, scale your axes. What are you counting by? Are you counting by 1s? Are you counting by 2s? Identify both of your asymptotes with dotted lines. Identify your intercepts. I should see ordered pairs on your paper at 0, 0.6 and at 1.5, 0. Okay, so all those details are important. Okay, now back to our document, because the last piece of the puzzle is having a context, a word problem. So let me go back to your document here. So you guys are going to do number 2, obviously, on your own, and you're going to put both graphs, the first graph that we did together and the second graph that you do all by yourself. So that'll complete the first page. And then this back page, okay, so I'm going to let you fill in what the input and output are. Just read the context carefully, identify who's in, who's out. But for the horizontal asymptote and the practical meaning, and then also some domain and algebra. So the horizontal asymptote, once again, is the coefficients of the variable. Horizontal asymptote is the coefficients of the variable. So where is my variable? It's right here. Where are the coefficients? They are right here, 135 and 0.5. So as far as my horizontal asymptote is concerned, it is at whatever 135 divided by 0.5 is. Okay, you need to go away. There we go. Ah, no, wait, sorry. Go back. There we go. So text, here we go. So the horizontal asymptote is whatever 135 divided by 0.5 is, which I know is 270. Okay, so the value of the horizontal asymptote in this problem is 270. Now we usually call it by its output letter, which for this particular problem is F for fish. So the F equals 270 is our horizontal asymptote. Okay, but what does it mean? So keep in mind that horizontal asymptotes are barriers. They're not errors, they're just barriers. So if you were to graph this function, which I encourage you to do so in Desmos, we will in a minute also, but if you graph this function, you're gonna see that it's increasing, but it's not increasing indefinitely. It reaches like an upper limit. And so keep in mind that we're talking about the letter F right now, which by the way, stands for fish. So when you say that the horizontal asymptote is at F equals 270, what you're saying is that the number of fish will not actually reach 270. No, remember, that's the barrier, but it will approach 270. And the other thing to keep in mind is, remember that horizontal asymptotes are the end behavior, meaning this isn't going to happen for like a long time. You're not going to see 270 fish in this fish tank in like the first month or the second month or even the third month or the 10th month. It's going to take many months for this number to ever be visible. Remember our conversation about horizontal asymptotes. You have to plug in a really big input for this number to even come close to showing up. So the number of fish will approach 270 as the months go by. You have to acknowledge that time has got to pass before you're ever gonna see this happen. So I'll be looking for a phrase like this on your exam. It might not be about fish, and it might not be months, it might be years or days or hours, but nonetheless, something will be approaching its limit or its barrier as time passes. So that's kind of what I'm looking for when it says state the practical meaning of a horizontal asymptote. The domain versus the practical domain, I am going to let you think about that one on your own. Think about the domain of a rational function, something you had to do up here as well. So think about the domain of a rational function, but then also keep in mind, this is absolutely a word problem. So read it very carefully because there's a clue in the paragraph that tells you where the practical domain should be. So you're going to have two answers on number 3. You're going to tell me what the domain is, just of the formula itself, and then you're going to read the paragraph carefully and you're going to decide what the practical domain should be instead. 2 answers. Okay. Last but not least, this is the last one that I want to make sure that we talk about just briefly. So solving for when, oh, that should say F, not P, F. That's a typo, I'm sorry. Solving for when F of M equals 187. Okay, so notice that this is an output value of 187. So if I were to go into my Desmos, 90 plus 135, okay. If I go into my Desmos and just do a regular function, y equals 90 plus 135x divided by 1 plus 0.5x x. Okay, so keep in mind when you put it in Desmos, it's not fancy variables anymore. It's just x's and y's, or if you really wanted to, you could say f of x, but nonetheless, no fancy variables. So the window, first of all, sucks because remember that the horizontal asymptote was 270. So yeah, I'm gonna go into my wrench and I'm gonna make my y-axis go all the way up to 300. There we go, much better. Okay, so this is the practical portion of the graph. A hint for your practical domain. This is the practical portion of the graph. And as you can see, it definitely reaches a barrier up there at 270. This was the horizontal asymptote that we already talked about. Check that out. Beautiful. But now for that last question, it's asking us to find when the output value is 187. So for Desmos purposes, how do you tell Desmos, hey Desmos, I want an output of 187. Output, the letter y equals 187. And certainly you can just intersect it and call it a day. Like you're done. The answer is 2.33 months. Or 2.34 months if we round. So once again, I cannot stress enough, intersect method, ladies and gents, is your best friend. Just know how to use your technology and you can always answer plugging something in or using it as an output, of course, with your y equals. But one more time, let's talk about the algebra. So if I wanted to do this very same question with a pencil and paper. So my formula was 90 plus 135m all over 1 plus 0.5m. And now here we are wanting to find an output of 187. So once again, just acknowledging that 187 is the output, so it goes on the outside. Now, how to solve this, guys? Same thing as the horizontal intercept. The only reason this equation is intimidating is because it's a fraction. So step number one, get rid of the fraction. What's the opposite of division? Multiplication. So you're going to have 1 plus 0.5m getting multiplied. Now, what was the whole point of that multiplication though? Again, it was to get rid of that division. So on the left-hand side, the whole point is that you just got rid of the denominator. Now on the other side though, this time, unfortunately, it is not just a big fat zero. Remember on the horizontal intercept, it just got zeroed out? Well, sorry, this isn't the horizontal intercept. You actually have 187. And notice you're now multiplying the 187 by that entire bottom. So you do need to distribute. So 187 times 1, and also 187 times 0.5. Let's see, what's 187 cut in half? It is 93.5, I believe. 93, yeah, I think so. Let's do a quick fact check on that. Mental math has never been my forte. 187 times 0.5, 93.5, okay, sweet. Okay, so you've gotten rid of the fraction. That's definitely a huge step in the right direction. And now you just have to decide, variable m. Now you just have to decide which way you want to move your variables. So do you want to bring the 93s over to the left, or do you want to bring the 135s over to the right? I personally would like to bring my 93s over just so that I can keep my variable positive. In the end, it doesn't matter. Just pick a side and go for it. So now on the left, we'd have 90 plus 135 minus 93.5. 135 minus 93.5 is 41.5. 41.5. Those are my m's. Equals 187 is still there. That has canceled out. Okay, cruising right along. minus 90 from both sides. So we are at 41.5 is equal to, what is that, 97? And then divide by, I keep losing my M. Guys, don't lose your M. I keep forgetting to write my M. Divide by 41.5 on both sides, 41.5, and 97 divided by 41.5 is 2.337. M equals 2.337. Please tell me that's what we got on Desmos too. It should have been. Should have been, should have been, should have been. Yes, totally is. Okay, so again, guys, I think you know me by now. You're allowed to use your Desmos. I'm not going to take away your Desmos. However, it is my job to make sure that you can also be algebra students. And so if you had to, you can take your 187 and put it on the outside of your formula and then use inverse operations. Solve for M, solve for M, solve for M. Inverse operations, undo, 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 until you have M by itself. All right, so pretty please just humor me and make sense of this algebra. Even if you end up using Desmos in the future for my class, that's okay. You're just going to tell me on exam day, I put this in line 1 of Desmos. I put this in line 2 of Desmos. I touched where they intersected and I got blah as my answer. Excuse me, that's totally fine, but humor me. Make sense of these steps. Try to understand every single one of them. And if you absolutely had to do this on your own someday, I would like to think that you could. You should be able to do this if you had to. Okay, that, friends, is a wrap with rational functions and halfway through your very last unit of this class. Crazy. Okay, we will talk to you soon. Hope everyone is well.